It's March 20th, and I've been getting a lot of emails about problem number 3. Buster, get out of there. On the empirical formula homework sheet. So I'm going to go over it with you. It's a combustion problem. And so we have a 1.20 gram sample. And combustion of a hydrocarbon makes carbon dioxide and water. So I'll just say combustion yields. And the oxygen is drawn in from the air, so you cannot use the mass of CO2 or water to get the percent oxygen. So let's go over this real slowly. So we get 2.92 grams of CO2. Did I bring my calculator? Yeah. And we have 1.22 grams H2O. So your first step is to find the percent carbon and percent hydrogen in your sample. And remember, your sample size is 1.20 grams. So 2.92 grams CO2 times a mole of CO2 over approximately 44.02 grams CO2 times 1 mole carbon, oopsie daisy, yeah, that's right, sorry, to 1 mole CO2 times 12.011 grams carbon, 2 mole carbon. That's going to give us our mass carbon, which comes out to be something, I want to put, can we pause it or we can't pause it?
No, stop her.
Okay, 2.92, did you stop?
Mm-mm.
Oh, okay, 12.011 divide 44.02. So that comes out to be, if I did it right, 0.797 grams carbon. So we're going to do the same with the water. 1.22 grams water times 1 mole water over 18.02 grams water times 2 mole hydrogen to 1 mole water times 1.008 grams hydrogen to mole hydrogen. So this strictly gives me the grams of carbon and now the grams of hydrogen. 1.22 times 2 times 1.008 divide 18.02 gives me 0.1364 grams hydrogen. I'll round to the correct number of sig figs at the end, but empirical formula, remember, is a mole to mole ratio, so that would be infinite sig figs. Okay, so I'm going to find the percent carbon is 1.22 grams over 1.20 gram sample times 100. That doesn't make any sense, does it? How could, oh no, I'm sorry, I did the wrong thing. I'm going, how could it be more than the sample? I'm sorry, guys. 0.797 grams carbon over 1.20 grams sample times 100. And percent hydrogen is going to be the mass of hydrogen over 1.20. 0.1365 grams hydrogen over 1.20 grams times 100. Okay, so I'm going to erase this, and let's do our second step. For the second step, we're going to get our percents, subtract them from 100, because remember, every sample size is 100% sample size. So our compound has 66.4% carbon and 0.2, 11.33% hydrogen, and I'm going to add these up. And subtract from 100 for the percent oxygen, because the substance is pure and we have 100% sample size. So let's see what we get. Of course, I should have worked this out before I came on video. So we get 22.27% oxygen. So now that we have our percents, 66.4 grams carbon, 11.3 grams hydrogen, and 22.3 grams oxygen in my sample, because percents can be converted to grams at this point, and that adds up to hopefully close to 100. Let me just do it real quick. Yeah, it's fine. It's close enough to 100.
That's exactly.
Okay, so now we're going to find our moles, because remember, empirical formula is a simplest whole number ratio of atom to atom in a molecule. So we're going to find our moles. And after we find our moles, we're going to divide by our smallest one and hope that we get a nice whole number. But if we don't, it's not a big deal. We'll figure it out together. 66.4 divide 12.011. This gives me 5.528. 11.3 divide 1.008 gives me 11.210. So far it's looking pretty good. And then finally 22.3 divide 15.999 gives me, ooh, is that right? Okay, we'll see. It gives me 1.393. Okay, so we have 1.393 moles oxygen, 11.210 moles hydrogen, 5.528 moles carbon. And at this point, I'm going to erase so I can write it up here. We're going to divide by the smallest number of moles and hope that we get our simple whole number ratio. 11 moles hydrogen, divide by the oxygen moles are the smallest. And then finally, the oxygen will be 1. Okay, so this gives us 1. This gives us, I hope, something good. We'll see. Hopefully if my math is right. This gives us 8, so that looks pretty good. And the carbon gives us 4. So empirically, I have C4H8O. That's my empirical formula. That's the simplest whole number ratio. Then the problem gives you the molar mass and asks you for the molecular formula. So the molecular, we have empirical formula mass is equal to 12 times 4 is 48, plus 8 is 56. It's about 72. Did I do that right? 48, 8, 56, 56, 16, yeah, 72 grams per mole. That's approximate, you guys. And we're told molecular mass is 216 grams per mole. So molar mass over empirical formula mass will give you the subscript multiplier. 216 divide 72. I hope this comes out to a nice number. It does. It comes out to 3. So 216, the units cancel, divide 72 equals 3. That's the coefficient I multiply every subscript by for the molecular formula. So we get C12H24O3. And that's all there is to it. I always like to check my molar mass.